Hello students, I welcome you all back to my channel. Once again, this video we are going to learn a very important topic from thermodynamics, that is we call it as Carnot cycle, under which we see or we will learn the conversion of heat into work. Okay, so what this Carnot cycle is and how this Carnot explained how maximum amount of heat can be converted into work. Okay, so all those we will be learning under Carnot cycle. So take a fresh new page and put the side heading Carnot cycle. Besides that, write down conversion of heat into work. Okay, generally we all know that equal amount of heat will not be converted into equal amount of work. Okay, but here in Carnot cycle, the process in which we what we observe here under Carnot cycle, we find that there will be maximum conversion of heat into work done. Okay students, underlined, right, and also mark it as an important question. So this Carnot cycle was proposed by Sadi Carnot, S-A-D-I C-A-R-N-O-T. So in short we call it as Carnot cycle. Okay, now this person, what he observed was there was maximum conversion of heat into work done in a cyclic process. Do you remember students what is this cyclic process? Cyclic process means there are a series of steps taking place, and also we find that the system reaches to the original state. That means all the steps whatever they are taking place in a cyclic process, they are carried out reversibly, and such a reversible cycle we call it as Carnot cycle. Okay, so write it down. Sadi Carnot observed that the maximum conversion of heat into work. Can you see students? Right. Heat into work occurs in a cyclic process in which series of intermediate steps take place by which a system can be brought back to the original state or to its initial state. So the meaning of this, brackets write down, that is where the steps are carried out reversibly. Okay, close the brackets, and such a reversible cycle is called as Carnot cycle. Okay students, written, underline, such a reversible cycle is called as Carnot cycle, underline. Next, so what was this Carnot cycle and how he explained? Let us learn students. Here we can see that he proposed a theoretical engine or a hypothetical engine that is called as Carnot or heat engine in the year 1824. Okay students, he proposed a theoretical engine called as Carnot engine or heat engine for the first time students in the year 1824. And now this heat engine or the Carnot engine, it works on the basis of Carnot cycle. Okay, so you understood what Carnot cycle is in the above paragraph, right? Now this heat engine, it works on the basis of Carnot cycle and can convert heat into maximum work. That's the main principle of Carnot cycle students, as we have seen in the above paragraph. Okay, so the main motto of Carnot cycle is conversion of maximum heat into maximum work. Okay, so here the heat engine proposed by Sadi Carnot, it works on the basis of Carnot cycle, and also it can convert heat into maximum work. maximum work, and also this heat engine is thermodynamically reversible, students. Can you see? Please write down, students. And also thermodynamically reversible. Okay. Now, what are the important parts of this theoretical or hypothetical engine? Okay. So, this engine, it was devised for the first time by Carnot, which works on the basis of Carnot cycle. Now, if we look at the parts of this theoretical or hypothetical engine, have you completed the second paragraph? Next, below that, write down the important parts of. So, first part of the heat engine or the Carnot engine. First one, students, it is the heat reservoir, or we call it as a source which is at a constant high temperature. First part of the Carnot engine, a source, that is the heat reservoir. The first part of the theoretical engine, heat reservoir which is at constant high temperature. Next, second one, a sink which is at lower constant temperature, students. A sink at lower constant temperature which absorbs heat. A sink at lower constant temperature, what is it doing? It is absorbing the heat which is coming out from heat reservoir. That is the first part of the theoretical engine. Okay. First part is heat reservoir, students. Whatever heat is coming from heat reservoir, that is being absorbed by the sink which is at lower constant temperature. Second part have you written? Which absorbs heat given out by the heat reservoir. By the heat reservoir. Next, third part is the working substance in the process of Carnot cycle, students. So, what is this working substance? Here the working substance is taken as 1 mole of ideal gas, which is taken in a cylinder which is fitted with a frictionless and weightless piston, and this is considered to be the working substance in this process. Okay. So, the first one is source, second one sink, third one is the working substance. First one heat reservoir at constant high temperature, second one sink at constant low temperature, third one the working substance. Can you see this point, ma? 1 mole of ideal gas placed in a cylinder fixed with a frictionless and weightless piston, which is considered to be the working substance in this process. Written all the three parts of the theoretical engine. Now, the entire process in Carnot cycle, we can see that the whole process in the Carnot cycle, it occurs in 4 stages. Okay, or 4 steps. The entire process in Carnot cycle takes place in 4 steps. And also, these 4 stages or 4 steps, they occur in a cyclic process as we have seen in the beginning. Okay, students. So, cyclic process means after undergoing all the 4 changes, the system returns back to the initial state. Initial state or original state. Okay. The system returns to its original state. And the result is there will be no change in the internal energy of the system. Okay. So, the entire process in Carnot cycle takes place in 4 stages, that too in a cyclic process, where after undergoing all the 4 changes, after going through all the 4 steps, system returns back to its original state. Okay. Now, what is the result of all these 4 steps, students? There will be no change in the internal energy of the system. Completed? Now, let us see what these four stages or what these four changes that the system is undergoing in Carnot cycle. Ready? Number one, put the side heading. Put the side heading. Isothermal expansion of the gas. You know what is meant by isothermal? You know what is meant by expansion. Okay? So, individual terms, you know the meaning. Written students, number one, isothermal expansion of the gas. Isothermal expansion of the gas. Kindly underline the side heading. So what happens in isothermal expansion of the gas? The working substance. Tell me, what is the working substance in Carnot cycle? Do you remember? That is the third part of the theoretical engine. What is it, students? 1 mole of ideal gas. Very good. So the working substance, that is the ideal gas. Ideal gas, what is it doing, ma? It absorbs some amount of heat. Let us say Q1 from the heat reservoir. Heat reservoir, we considered it as the source which is at constant high temperature. Let it be T1, and after absorbing Q1 amount of heat, the ideal gas expands isothermally from a volume V1 to V2. Carefully note down the changes, students. Isothermal expansion of the gas. What is happening here? The working substance. What is the working substance? Again, I am telling you, that is the ideal gas absorbs Q1 amount of heat. Q1 amount of heat from the source. What is the source? That is the heat reservoir. From the source or heat reservoir which is at a temperature T1 and expands isothermally from a volume V1 to V2. Written? Next, below write down. So let the work done be W1, and we all know that W1 is equal to this. We have already derived, students, derivation of work done. You can go back and check your notebook that the work done W1 here can be taken as 2.303 RT1 log V2 by V1. Okay, so T1 is the temperature of the heat reservoir, and next the gas expands isothermally from a volume V1 to V2. Therefore, here W1 is equal to 2.303 RT1 log V2 by V1. Okay, students. Right? You can mark it as equation number 1, or you can simply leave it, because in the next almost at the end of this topic, we will be marking the equation numbers again. Okay. Next, below write down. After writing for work done, W is equal to, below write down. From first law of thermodynamics, what do you know from first law of thermodynamics? What is the mathematical statement of thermodynamics? Write down, Q is equal to delta E plus W. Written, students? Below. But delta E is equal to 0. Change in internal energy is 0, as this is a isothermal expansion. Therefore, Q value will be equal to W. Okay, so whatever the work done here, we have taken it as W1, right? So W1 value, we have mentioned it as 2.303 RT1 log V2 by V1. The same will be the value of Q1. The amount of heat absorbed from the source value will be 2.303 RT1 log V2 by V1. Completed? Next, second process. Put the side heading, adiabatic expansion. First one is isothermal expansion. Second one is adiabatic expansion. You know what is meant by adiabatic. You know what expansion is. Okay. Now, what is this adiabatic expansion? So, previously, the working substance, it absorbed heat from the heat reservoir. Now it is removed from the heat reservoir. That means it is in contact with the heat reservoir. That is the cylinder in which the gas is taken is now removed from the source. That is heat reservoir. Now where is it placed? It is placed in contact with a perfect insulated material. There will be no heat transfer. Okay. So, what is the meaning? It is placed in contact with the perfect insulated material means we say that the system is subjected to, what is the system here? Ideal gas. Okay. Now, it is subjected to reversible adiabatic expansion. You know what reversible process is. You know what adiabatic process is. You know what expansion is. Okay. So, from heat reservoir, the cylinder is placed in contact with an insulated material. That means the system is undergoing reversible adiabatic expansion. So, what does it mean? It means that the ideal gas expands from a volume V2 to V3. Okay. In the first step, it expanded from a volume V1 to V2. In adiabatic expansion, the gas expands from a volume V2 to V3. Okay. Hope you are able to follow and write down, students. Now, in this expansion process, we can say that some work is being done during expansion. Okay. Some work is done during expansion, but as this is an adiabatic process, what will be the change in heat, students, in an adiabatic process? Do you remember? Yes, the change in heat will be 0. Those who are giving the answers, very good, ma. You are following. That means you have completed the previous topics. Okay, so in an adiabatic process, change in heat will be 0. Change in heat will be 0. Change in heat will be 0 means what? There will be no heat coming inside and going outside. Okay, so no heat enters or leaves the system. That's what you mentioned in the brackets. Hence there will be a decrease in temperature from T1 to T2. So, in the first step, the temperature of the heat reservoir is at T1. Now, as there is no heat transfer and also as it is an adiabatic expansion, there will be a decrease in temperature from T1 to T2. Completed, students? From T1 to T2. Are you able to write down, ma? Shall I show it once again? Okay, or else you can take a screenshot without wasting any time. Okay, so now below write down, let the work done by the system in this process, let the work done by the system in this process be W2. First step we have considered it as W1. Now we will consider it as W2. Written below write down. Since what is this process, ma? Second step, adiabatic expansion. Okay. Since the process is adiabatic, we all know that Q will be 0. Change in heat will be 0. That is Q is equal to 0. Next, below write down. From first law of thermodynamics, we know that Q is equal to delta E plus W. Delta E plus W. Okay. Now, from this equation, delta E, students, what it will be? Bring delta E left side. What it will be, ma? Q minus W. Very good. Next. So, Q is 0. What will be the value of delta E now? Delta E is equal to 0 minus W means delta E is equal to minus W. Okay. In this step, what we consider work done as W2. So, delta E will be equal to minus W2. Now, but delta E by delta T is equal to CV, heat capacity at constant volume. This also we have completed in the earlier days, in the previous classes. Please go through once. Delta E by delta T is equal to CV. Now, what would be delta E from this equation? Cross multiplication. Delta E will be equal to CV into dt. CV into dt. Below. Therefore, delta E will be equal to CV into T1 to T2. Delta E will be equal to C1 into T1 minus T2. Okay. Change in temperature. Fine, ma. Below write down. So, delta E is equal to minus W2. But the delta E value we got it as CV into T1 minus T2. The same we can write final step as hence minus W2 is equal to CV into T1 minus T2. Written, ma? Next, third step. Isothermal compression. Isothermal compression. Put the side heading. Isothermal compression. We have seen isothermal expansion, adiabatic expansion. Now the third step is isothermal compression. So in the second step, cylinder was in contact with the perfect insulating material. Now cylinder is removed from the insulating material and placed in contact with the sink, which is at lower constant temperature. Go to the parts of the theoretical engine, ma. Second part. Okay, second part is the sink and it is at a constant lower temperature T2. Okay, cylinder is now brought in contact with the sink which is at a lower constant temperature T2. What does it mean? It is in contact with the sink means the system is subjected to reversible isothermal compression. Okay, the gas is being compressed now. So automatically there will be a decrease in volume, as you all know, from V3 to V4. There is a decrease in volume. There is a decrease in volume from V3 to V4. Second step, gas expands from a volume V2 to V3. Here, gas is being compressed, hence the volume is also decreased, that is from V3 to V4. Written, ma? Right. Now, during compression, what is being done? Some work is done on the system. Okay. So, work done on the system and work done by the system. This also we have learned. So, in thermodynamics, students, don't simply come in the middle and try to learn the topics from the middle. Okay. There will be a connection from the first topic. So, if you read the first topic, second topic, third topic, then only you can understand the fourth topic. Okay. So, now during compression what is happening? Work is done on the system and also we observe that some heat is being produced by the gas. Okay. Why heat is produced by the gas? Because gas is getting compressed here. That is the reason work is done on the system and hence some heat is produced by the gas. This is all interconnection, ma. Okay. During compression, gas is being compressed. So, work is being done on the system. So, on the system, gas is releasing some heat. Now, where is this heat going? Here the cylinder is in contact with what? With the sink. So, whatever heat is coming out or whatever heat is released by the gas, it will be transferred to sink. It will be transferred to sink. Written? Now below write down. Let the work done in this process be W3. In this process be W3. In this process be W3 and is given by below write down W3 is equal to 2.303 RT2. First step we mentioned it as RT1, heat reservoir at T1. Here sink at T2. Okay, so W3 is equal to 2.303 RT2 log V4 by V3. Okay, log V4 by V3. Written. Students, in the first step we marked it as equation number 1. Please erase it. Okay, later it will be a confusion again. So here all we did not mention it as equation 2 and 3 like that. Just simply erase it. Okay. Okay, students. Next, since the process is, what is this third step? Isothermal compression. Isothermal compression means again change in internal energy will be 0. So from first law of thermodynamics, again the same equation, Q is equal to delta E plus W. Okay, so delta E 0 means Q is equal to W. So here work done we considered it as W3. So W3 is equal to Q3. So whatever value is for W3, that will be equal to Q3. So you can write down W3 is equal to Q3 is equal to 2.303 RT2 log V4 by V3. Put it in a box. Next, coming to the last step. What would be the fourth step? Yes, this is adiabatic compression. Second step was adiabatic expansion. Now what is happening in the fourth step, students? In the fourth stage or the last stage, the cylinder is now removed from the sink. Third step, it is brought in contact with the sink, right? Now it is removed from the sink and again placed in contact with the insulating material. Insulating material. What does it mean? We are placing the cylinder in contact with the insulating material means the gas is subjected to reversible adiabatic compression here. Don't get confused. This is compression. Reversible adiabatic compression. Underline that point, Reversible adiabatic compression. Okay. So, hence there will be a decrease in volume. Hence there will be a decrease in volume from third step we have seen decrease in volume from V3 to V4. Now fourth step there is a decrease in volume from V4 to V1. That means the initial state or the original volume. Original volume. Okay, and as a result what happens, students, there will be a rise in temperature from T2 to T1. Okay, now it is removed from the sink, which is sink means what? It is at a lower constant temperature T2. Okay, so therefore now it is in contact with the insulating material. So decrease in volume from V4 to V1, going back to the original state. So the same way temperature also from T2 to T1 we can see going back to the initial stage of temperature. Okay. Have you seen, Are you able to write in the final step? Cylinder is removed from the sink and placed in contact with the insulating material. That is, the gas is subjected to reversible adiabatic compression. Hence, there is a decrease in volume from V4 to V1. Brackets mention it as original volume. And as a result, the temperature increases from T2 to T1. That means going back to the initial state. So below write down, let the work done in the fourth step be W4. So first W1, second W2, third W3, fourth W4. Okay, again below. Since the process is adiabatic, change in heat will be 0. Q is equal to 0. From first law of thermodynamics, Q is equal to delta E plus W. Delta E is equal to Q minus W. Delta E is equal to 0 minus W, that is minus W. So here the work done, we have considered it as W4. Therefore, delta E is equal to minus W4. Clear? Below write down. But delta E by delta T is equal to CV. Delta E by delta T is equal to CV. Tell me what delta E is equal to, like we did in the previous step. CV into dt is equal to CV into T2 minus T1. Okay. Now delta E is equal to minus W4. Delta E value we got it as CV into T2 minus T1. So therefore minus W4 will be equal to CV into brackets T2 minus T1. Written, put it in a box, that is W4 value. Now we have almost come to the end of the this topic, students. Below write down. So now total work done by the system. How do we get total work done by the system? By adding all the works done in all the 4 steps. Is the sum of the work done in all 4 steps. Below write down. W is equal to W1 plus W2 plus W3 plus W4. So you have the values of W1, W2, W3, W4. Fatafat below write down. W is equal to written W1 value 2.303 RT1 log V2 by V1. Now there minus W2 is equal to we have na. So here you just write down minus CV into T1 minus T2 plus 2.303 RT2 log V4 by V3. Here also minus CV into T2 minus T1. Okay. So minus W2 we are shifting it to right side. Minus W4 we are shifting it to right side. Written below write down is equal to below write down 2.303 RT1 log V2 by V1. There is no change, students. Minus CV into T1 minus T2 plus 2.303 RT2 log V4 by V3. Here I changed the sign. So what happened? Plus CV into T1 minus T2. What is in the above step? Minus CV into T2 minus T1. So if we change the sign, it becomes CV into T1 minus T2. So why did I do like that? We can cancel out na. Minus CV into T1 minus T2, that is the second one, and fourth one can be cancelled out. Minus CV into T1 minus T2 plus CV into T1 minus T2. Cancel. Now what remains below? 2.303 RT1 log V2 by V1 plus 2.303 RT2 log V4 by V3. Here mark it as equation number 1 ma. There you please erase it. So those who are enjoying, you can please raise the hand in the comment section. W is equal to 2.303 RT1 log V2 by V1 plus 2.303 RT2 log V4 by V3. Equation number 1. So here now comes there a diagrammatic representation. Okay. So just give me a moment. I will show you the diagram. You can draw that one. Take a pencil and scale ma. So write down in the draw this diagrammatic, show this diagrammatic representation. All the 4 stages. Isothermal expansion. Mark the 4 corners as A, B, C, D. Near point A, you can write T1 V1. Next point B, isothermal expansion. V1 to V2, so T1 V2. Next curve BC represents adiabatic expansion. At point C, mark it as T2 V3. Next CD represents isothermal compression. Point D, T2 V4. And DA curve, adiabatic compression. Okay, so you should be carefully looking at these curves. Now these curves will help us to proceed in the derivation, further in the derivation. Completed, ma? So now write down below. From the curve BC, look at the diagram. At point B we have T1 V2. At point C we have T2 V3. Okay. So do you remember we have learned one answer like show TV to the power gamma minus 1 is equal to constant. Okay. So that means here we can mention it as T1 V2 to the power gamma minus 1 is equal to T2 V3 to the power gamma minus 1. Based on that, ma. Okay. Now from this T1 by T2 is equal to V3 by V3 to the power gamma minus 1 by V2 to the power gamma minus 1. So both have the same power. This can be written as T1 by T2 is equal to V3 by V2 whole power gamma minus 1. Mark this as equation A. Next, similarly from the curve DA. At point A we have T1 V1. So T1 V1 to the power gamma minus 1 is equal to, at point D we have T2 V4, T2 V4 to the power gamma minus 1. I will just give 30 seconds like from curve BC. Can you just write the next step, ma? So T1 by T2 is equal to V4 to the power gamma minus 1 by V1 to the power gamma minus 1. This can be written as T1 by T2 is equal to V4 by V1 whole power gamma minus 1. Mark this as B. Now what can we infer from equations A and B? Both the equations left side if you observe there is T1 by T2, T1 by T2. Now both the right hand side portions can be made equal. So from equations A and B, V4 by V1 whole power gamma minus 1 is equal to V3 by V2 whole power gamma minus 1. Now how to solve this? So both sides gamma minus 1 will be cancelled. So what remains? V4 by V1 is equal to V3 by V2. So from this V1 by V2 will be equal to V4 by V3. Mark this as equation C. You can, if you cross multiply, you will easily understand this one. Next, substituting the value of C in equation 1. Go back to equation 1. Okay, write down. W is equal to 2.303 RT1 log V2 by V1 plus 2.303 RT2 log V1 by V2. There in equation 1 we have V4 by V3, but from C we have a V4 by V3 value as V1 by V2. So we can substitute here log V1 by V2. Okay. Next, a small change has been done here, ma. What is that change? See, 2.303 RT1 log V2 by V1 is same. But now the plus has been changed to minus. Why? Minus 2.303 RT2. In the above step, it is log V1 by V2. But here, it is changed log V2 by V1. Therefore, now it is a minus sign. So, what can be taken common out? 2.303 in both the terms we have. R is common. Next, log V2 by V1 is common. Okay. So, take all these common out and in the brackets what remains, ma? Complete. Those are able to write, you please write down the next step. Very good. Those who have written, check the next step. In the brackets we have T1 minus T2. Mark it as equation number 2. So equation 2 represents, so what do we understand from this equation 2? It represents the total work done in the complete process. Okay. So this tells us the complete work done. Now, what does equation 1 tells us? Equation 1 tells us the heat absorbed is given by, that is equation 1 ma. Go back and check equation, not very first step. Just before we have mentioned one step as equation 1. That is 2.303 RT1 log V2 by V1. That is equation 1. Okay. So the equation 1 represents heat absorbed and equation 2 represents total work done. Now taking the ratio of these two, below write down. Therefore, total work done by heat absorbed is equal to 2.303 R log V2 by V1 into T1 minus T2 by equation 1 ma. 2.303 R log V2 by V1 into T1. So above and below the same terms will be cancelled out. What remains? T1 minus T2 by T1. This is equal to phi, which is called as efficiency. Put it in a brackets ma. Put it in a box. Efficiency is equal to phi, which is denoted by phi, which is equal to T1 minus T2 by T1. What does this infer? This infers that the efficiency of Carnot cycle depends on the temperatures of source and the sink. We have seen in the beginning, source is at a temperature and sink at a temperature. So it depends on the temperatures of both source and sink as well. Okay. So now we will see what is this efficiency. So if you are asked to define efficiency, what will you write? Put the side heading efficiency ma. Almost. Just 1 or 2 minutes more. Put the side heading efficiency. The ratio of total work done. The ratio of total work done and amount of heat absorbed. Heat absorbed in a cyclic process is called as efficiency and is denoted by phi. In some textbooks you can find it as eta, students. Okay. So you can write, you can use any letter. So phi is equal to T1 minus T2 by T1. So final statement, Carnot theorem. Put the side heading Carnot theorem. So what does it state? It states that all cyclic machines which are working between same temperatures of source and sink will have the same efficiency. Written, all cyclic machines working between same temperatures of source and sink have the same efficiency. Okay. So this is all about Carnot cycle, students, conversion of heat into work. So Carnot observed that maximum heat can be converted into maximum work in a cyclic process, and he called it as Carnot cycle, and we have seen it takes place in 4 stages, and also calculated the total amount of the work done. Okay, so draw a line till here, students. Carefully write down all the points in your notebook, and this is mark it as a very, very important question. Fine? Okay. So we will meet you in the next video with a new topic. Take care, students. Thank you for watching.